Hello students, welcome back to our channel Learn from Born Teachers. This is the second part of Structure of Atom NCERT Chemistry Plus 1 chapter. Today we'll be discussing about cathode ray tube experiment and the properties of cathode rays. Cathode ray experiment was a result of J.J. Thomson experimenting with cathode ray tubes. During his experiment, he discovered electron. He was even awarded a Nobel Prize in Physics for this discovery. J.J. Thomson conducted cathode ray tube experiment with this apparatus. You can able to see a cathode and anode connected to a high voltage battery. A gas filled at low pressure in this tube. This was the apparatus of J.J. Thomson's experiment. He found out that a ray is generating from cathode and it is moving towards anode. Since the anode is positively charged, he called this rays as cathode rays. So let us check the important properties of cathode rays. Cathode rays travel in a straight line. Cathode rays are made up of negatively charged particle and he called it as electrons. Cathode rays are deflected by electric and magnetic field. Cathode rays show heating effect. When cathode rays are focused on a thin metal foil, it gets heated up to incandescence. What is incandescence? Incandescence is the emission of electromagnetic radiation from a hot body as a result of its high temperature. Cathode rays ionize the gases through which they travel. Cathode rays produces X-rays on hitting a metallic target. You can able to see which are all the source of cathode rays. A metal electrode that we will be using as cathode, gas atom in the medium. So these are the source of cathode ray. Cathode rays generating from cathode. That is why the name of the ray itself being called as cathode rays. Determination of E by M value. E is nothing but charge, M is mass. J.J. Thomson conducted an experiment to find out the value of E by M. He got the E by M value as 1.76 into 10 power 11 coulomb per kilogram. This ratio was found to be constant irrespective of the nature of cathode or the nature of gas taken in the discharge tube. Whenever he took different gases in the discharge tube, the E by M ratio will become the same. So he concluded that electrons are the basic constituent of all the atoms. Electron, the basic constituent of all the atoms. The charge of electron was found to be E is equal to minus 1.602 into 10 power minus 19 coulomb. This was found with the help of an experiment conducted by R.A. Millikan through his oil drop experiment. Determination of mass of electron. We have found out the charge by mass ratio by J.J. Thomson's method, and by R.M. Millikan's oil drop experiment we got the charge of electron as well. So from these values we can able to find out the mass of electron. Mass of electron is equal to charge by mass ratio, that is equal to 1.6022 into 10 power minus 19 coulombs by 1.76 into 10 power 11 coulomb per kilogram. So that we will be getting the mass of electron 9.1 into 10 power minus 31 kilogram. So we got the charge of electron 1.6022 into 10 power minus 19 coulomb, and we got the mass of electron as well, it is 9.1 into 10 power minus 31 kilogram. You should remember this, mass of electron is 1 by 1837th the mass of an hydrogen atom. So the ratio of mass of electron to the hydrogen atom, we can say that it is 1:1837. Thank you for watching. If you like this video, please hit the like button, subscribe and share with your friends.